Hey there, Math Club. Today's episode is a special mathematical adventure for younger listeners. So go get your kids, your nieces and nephews, your students, or any other youngins who might enjoy a math story made just for them. And that's not to say that you grown-up listeners won't enjoy it too. So stick around and listen with your kids. The more the merrier. We think it'll be best for about third grade and up, but you know your kids better than we do. So if you have an even younger learner who you think would enjoy this, bring them on over. And this is an interactive adventure. So listeners will probably want to keep a pencil and a few pieces of paper nearby. We've also created a really cool interactive webpage to go along with the podcast. Some kids might really like this and find it helpful while doing the problems. You can find it at bit.ly/mathclubjunior. Throughout the episode, there are a few spots where we think you'll want to hit pause and do some problem solving. You'll recognize those spots when you hear this music. And of course, you can pause or rewind parts of the show whenever you'd like. All right, is everyone ready? Good, 'cause here we go. Thanks for calling the Math Club. This is Noah. How can I math you? Oh, hi, Principal Honcho. How are you? Huh? Oh, my goodness. I'm so sorry to hear that. Is there anything we can do to help? Of course. We'll head over right now. Hey, who was that? That was the principal from my old elementary school. Is everything okay? It sounded pretty urgent. Well, my old teacher, Mrs. Morrison, broke her leg skateboarding to school this morning, and is going to be out for a while. But her class is supposed to have a pizza party today, and Principal Honcho needs a couple of subs who can handle all the mathy details. You know what? This sounds like a job for Math Club Junior.
Pete and Noah, thank you so much for hurrying over.
Our pleasure, Principal Honcho. Of course, we're glad to help.
Here's Mrs. Morrison's classroom. And look at this. Some of her students are so eager that they're already lined up by the door. Good morning, everyone. The rest of the class will be arriving in just a minute. And here's a note with the pizza party tasks that she left for you. But
What's the matter?
the students work so hard to collect money for their pizza party, but the money is locked in Mrs. Morrison's classroom safes. And I don't know the combination. She tried to tell it to me, but she had just broken her leg and was kind of rambling.
Well, maybe we can help. What did she tell you?
She said that the combination was half of 12, a third of 9, and a fourth of 20.
Oh, she was using fractions to tell you the numbers of the combination. If we can divide each of the numbers 12, 9, and 20 into groups of the right size, we can figure out what the combination is. The first number in the combination is half of 12. To find half of a number, we need to divide it into two equal groups. If Mrs. Morrison had said half of 6, the answer would be 3, since 6 is made up of two groups of 3. So, to start figuring out the combination, we'll have to find half of 12 in the same way. Right. And then she said 1/3 of 9. You can find that by dividing a group of 9 into 3 equal groups, which are called thirds, and counting how many are in one group. And finally, she said 1/4 of 20. For that one, picture dividing 20 things into 4 groups, which are called fourths, and counting how many are in one of those groups. Yeah, so let's write these fraction problems on our scratch paper, everyone. 1/2 of 12, 1/3 of 9, and 1/4 of 20. Ready to do some math? Hop to it. We'll be here when you get back.
Welcome back, everyone. Were you able to figure out the combination to the safe? What do you think it is?
Let's check those numbers one at a time. The first one was 1/2 of 12, which is 6. The second one is 1/3 of 9, which is 3.
And the last one is 1/4 of 20, which is 5.
That means the combination must be 6, 3, 5.
Wonderful work, everyone. Pete and Noah, I leave the class in your capable hands.
Thanks, Principal Honcho. We'll take it from here. Good morning, class. My name is Noah, and this is my friend Pete. We're subbing for Mrs. Morrison today, which means we get to help you get ready for your pizza party. Pete, didn't Principal Honcho hand you a note from Mrs. Morrison? She sure did. It's right here. Dear Math Club Junior, that's Noah and me here, and all of you out there listening in. Before you can enjoy your well-earned pizza party, you'll need to figure out how much pizza to order. The money our class collected for the party is in the classroom safe, and I'll make sure Principal Honcho has the combination. Make sure you have enough to tip the delivery driver when they bring the pizzas. Have fun. Signed, Mrs. Morrison. Okay, class, we want everybody to get 2 slices of pizza. There are 25 students, so how many slices will we need? It sounds like we need a total of 50 slices so that everybody can have 2. Wait, Pete, don't we get some pizza too? What do you say, class? Should we order enough so that all of us can really have 2?
Yeah!
All right. So now we need to start with 50, but then add 2 slices for Pete and 2 slices for me. How many slices is that? Right. 50 plus 2 plus 2 is 54. We need to order exactly 54 slices. You know, Noah, we should probably order 64 slices. 64? Why? 'Cause I'm really hungry. No, not fair. 2 slices for everyone, including you, Pete. So 54 slices it is. Let's see if we can figure out how many pizzas will be just right. And as a reminder, I'll write the pizza sizes on the board. A small has 10 slices, a medium has 12, and a large has 16. So, what combinations can we buy so that we get exactly 54 slices? And here's a tip. There's more than one combination that works. All right, everybody, ready, go. Okay, everyone, welcome back. How many different combinations did you find that can add up to 54 slices? If you said 2, that's exactly right. What's one of the ways to make 54 here, Pete? Well, here's the combination I thought of first. We could order 2 larges, 1 medium, and 1 small. That's funny, because the one I thought of first was 2 mediums and 3 smalls. Let's see how the math works out on your idea, Pete. Okay, sure. Since each large pizza has 16 slices, 2 larges would give us a total of 32 slices. A medium would give us 12 more for a total of 32 plus 12, or 44 slices. And finally, a small has 10. So if we add 10 to 44, we get a total of 54 slices. That sounds about right. And my idea was 2 mediums and 3 smalls. Since each medium has 12 slices, 2 mediums would have 24. Small pizzas are 10 slices each, so 3 of them would give us another 30, and 24 plus 30 also gives us 54. This is cool. We have 2 different options here. So we'll need to figure out how much each option costs. Oh, telephone. Why don't you guys wrap this up and I'll go see who that is. Mrs. Morrison's room, this is Noah speaking. Okay, sure. We can definitely do that. I'm working with another sub today. His name is Pete. Would it be all right if I send him down while I stay with the class? Great. He'll be there soon. Who just called? That was the librarian, Dr. Bookenbooger. He needs someone to come down and pick up a set of books for Mrs. Morrison's literature project. Oh, okay. You want me to go? Yeah, sure. We can send a group of student helpers to go with you. Sounds good. Hello, Dr. Bookenbooger. I'm Pete.
No, actually, it's pronounced Bookenbouger.
Isn't that what I said?
No, you said booger.
I said booger.
Well, you said Bookenbooger.
But isn't your last name pronounced Bookenbouger?
That's what... Why don't we start over? Hi, I'm Dr. Bookenbouger. You must be Pete.
That's right. Noah sent me over to pick up some books for Mrs. Morrison.
Ah, yes. Mrs. Morrison ordered a new series of books, and they've just arrived. Oh, and before I forget, one of the books was a little cheaper than we thought, so here are 2 shiny dimes to give back to Mrs. Morrison.
These are shiny.
I see you have some helpers with you. Are you all ready to take the books back to class?
I think so, right, everybody?
The class has really been looking forward to these. Make sure that when you read them, you start with the first one and read them in order.
Okay, but aren't they numbered?
Unfortunately, they are not.
Huh. Well, that's a little weird. Hey, I have an idea. If we look at the title page of each book, it'll tell us when the book was published. We'll just start with the one that was published first.
That is a good idea. It looks like you'll have to know how to read Roman numerals, though, because that's how the dates are written.
Oh, you're right. This book was published in the year MMXXI. Roman numerals are a numbering system that started in ancient Rome. The Romans used letters to stand for different numbers. You might have seen letters like these on a clock or as chapter numbers in a book.
It's also how games are numbered in the Super Bowl, or as I like to call it, the Superb Owl. That's librarian humor, you know.
Okay. Hey, here's another date. It's the Roman numeral MMXII. And the last one is MMXIX.
All right, helpers. For this task, we need to know what letters M, X, and I stand for.
You know what? Why don't we head back to the room and ask the rest of the class to help us figure out these dates? Kids, say thank you to Dr. Booger. Bougie. Thanks, Doc. We appreciate the help.
My pleasure.
And we'll make sure the books get back to Mrs. Morrison's room safe and sound.
Good luck with those Roman numerals.
Hey, everyone. Welcome back. Did you get the books? We sure did. And we got a math problem, too. We need to figure out what dates these 3 Roman numerals represent. MMXXI, MMXII, and MMXIX. Ooh, I love Roman numerals. They're my favorite kind of numerals. So, if I remember correctly, M is the biggest. Each M is equal to 1,000. X is in the middle, but it's a lot smaller. Each X is only equal to 10. And finally, I is the smallest. Each I is just 1. The Romans used other letters too, but for this task, we only need these 3. That's right. Now, these numerals were still common in the year MXIII. Let's figure out what year that was together. You might want to write down MXIII so it's easier to follow along. We need to add up each of the numbers that the letters stand for. We have 1M, which is 1,000, 1X, which is 10, and 3 I's, each of which is equal to 1. To get the total, we do 1,000 plus 10 plus 3 ones, which gives us 1,013. So the year MXIII is the year 1013. Wow, that was more than M years ago. Now, some of you may not have ever worked with Roman numerals before. So before we start, there's one extra rule that we need to tell you about. Usually, we just have to add up the numbers. But if a Roman numeral has a smaller number that comes before a bigger one, that tells us that we're supposed to subtract the smaller one from the bigger one. So, for example, the number ix is actually 9 because I is 1, which is smaller than x, which is 10. So, 10 minus 1 equals 9. Okay, class, here's your chance to figure out what the 3 years from the books are. Remember that once you've figured them out, you'll also need to put them in order from earliest to latest. All right, everyone. Let's see if you came up with the right answers. MMXXI is 2021 because 2 M's equal 2000, 2 X's are 20, and 1 I is 1. Add those up, and you get 2021. MMXII is 2012, 2 thousands, a 10, and 2 ones. And finally, MMXIX uses the subtraction rule that Noah shared a minute ago. It's 2019 because 2 M's are still 2000. Then we have an X, which is 10, but then we have an IX, which is 9. Add those up, and we get 2019. So the order we want to read these is start with 2012, then 2019, and finally 2021. Phew. Now that we have that sorted out, let's get back to our pizza order. We already figured out that we have 2 options for getting 54 slices, and now we need to talk about how much each option will cost. Oh, cool. Remind me what the 2 options were? Yeah, sure. We can get 2 larges, 1 medium, and 1 small, or we could get 2 mediums and 3 smalls. Both of those add up to 54 slices. That's great. So, class, here are the prices for each size pizza. You may want to jot this down on your scratch paper. A small pizza costs $13, a medium costs $15, and a large costs $20. Okay, kids, take a minute and figure out which combination would be cheaper. All right, everyone, let's go over how much it would cost to buy 2 larges, 1 medium, and 1 small. Since each large pizza costs $20, we could use either addition or multiplication to see that 2 larges would cost $40. A medium costs $15 more, and a small costs $13. So if we add everything together, we see that this option would cost 40 plus 15 plus 13, which is $68. On the other hand, we could also get 2 mediums and 3 smalls. Mediums cost $15 apiece, so 2 of them would be $30, and smalls cost $13 each, so 3 of them would be $39. 30 plus 39 equals 69, so this combination would cost $69, which is $1 more expensive than the other choice. Well, I know which option I think we should go for. So do I. The more expensive one. Because expensive things are fancier, and I could go for some grade A fancy schmancy pizza. No, you ting-a-ling. We should get the cheaper one. The more expensive combination isn't any fancier, it just costs more. So let's save ourselves $1 and order 2 larges, 1 medium, and 1 small. Okay, everyone, recess. I love recess. The fresh air, the fun and games, and all the math. Math? At recess? Where? Math's all around us all the time, Noah. You just have to look for it.
Are you two Pete and Noah?
That's us.
I'm Coach Gimme 20. Principal Honcho told me I could find you out here because I need a little help.
Sure, Coach. What can we do you for?
I've got 2 kids here, Lightning and Speedy. They both think they're the fastest kid in the school, so I told them we could settle that debate during recess. Here's what I think we should do. I'll take Lightning over to the track over there and have him run a lap while I time him. Can you guys take Speedy over to the other track and time how long it takes for her to run a lap?
Sure thing, Coach. Give me 20.
Great. Let's meet back here and compare times. Okay, guys. Lightning ran a 100-yard lap in 25 seconds. How'd Speedy do?
Well, Speedy ran her lap in 14 seconds. But I think we have a small problem.
We do? What?
A lap on our track is a different length than a lap on yours. You said that Lightning ran a 100-yard lap in 25 seconds, but Speedy ran a 50-yard lap in 14 seconds.
So, who's faster?
Well, that's what we have to figure out. Ready, kids? Who ran faster? Speedy, who went 50 yards in 14 seconds, or Lightning, who ran twice as far in 25 seconds?
So, were you able to figure out who's faster? If not, you better drop and give me 30.
Coach, give me 20? Isn't that just a bit too many?
What? You think they should drop and give me 10?
Okay, give me 20. Let's just look at our answers. So, we know that Speedy ran 50 yards in 14 seconds. Lightning ran twice as far, so if he was running at the same speed, it would have taken him 14 times 2, which is 28 seconds. However, it only took him 25 seconds.
And that means Lightning must have been running faster than Speedy.
I knew Lightning was speedy, and I knew Speedy was speedy, but I never knew Lightning was speedier than Speedy. Thanks for the help, you guys.
No problem, Coach. Give me 20.
Okay, class, it's almost time for the pizza party.
We ordered 2 larges, 1 medium, and 1 small, which came to $68. And each of you brought in $3, which Mrs. Morrison left in the safe. There are 25 of you here, so how much money do we have in all? What's 25 times 3? That's right. We have $75.
Noah, I think we have a small problem.
What's wrong? The pizza costs $68 and we have $75. That leaves us $7 to spare.
Yeah, but we need to tip the delivery driver, remember?
Oh, yeah.
A tip is extra money you give the delivery person as a way of saying thank you. Usually, we figure that out as a certain portion of the total cost of the pizza. So, for example, if the pizza cost $100, which would be a lot of pizza, I would give the driver 15% of 100, which is $15.
Okay. How much more money do we need?
For our order, we need to figure out what 15% of $68 is. The easiest way to figure this out is to start with 10% and then add 5% more, because 10 plus 5 is 15. 10% of $68 is $6.80. Another 5% would be half of that. So the total tip would be $6.80 plus half of $6.80.
Quick, class, before the driver gets here, how much should the tip be?
Were you all able to figure out what 15% of $68 is?
Our tip should be $10.20. Oh, and we'll only have $7 left after paying for the pizza. So how much more do we need in order to give the driver their tip?
That's right. We'll need $3.20 more than we have now.
Excuse me, everyone.
Hi, Principal Honcho.
We just got a call from Mrs. Morrison. Her broken leg is being taken care of at the hospital, and she had a minute to call with some important information. She said that there's an extra $3 in her desk drawer in case you need it.
That's great news. We can add that $3 to what we already have, and now we only need another 20 cents to cover the last little bit.
Oh, and guess what? My library helpers and I got 2 shiny dimes from Dr. Bookenbooger when we went to the library to pick up the literature books.
Perfect.
Pete, it's pronounced Bookenbooger.
Isn't that what I said?
Did somebody order some pizzas?
Great job, Math Club Junior. You solved every problem, and now it's time to party.
While I'm handing out the pizza, do you want to tell everyone how they can reach us if they have a question or want to tell us what they thought of today's math adventure?
Sure thing. We'd love to hear from all you math explorers out there. You can leave us a voice message on our SpeakPipe page, speakpipe.com/mathclubpodcast. Or you could send an email to mathclubpodcast@gmail.com.
We'd also like to thank our wonderful voice actors who appeared in today's episode: Carol King, Ed Meehan, and Kevin Corin.
Totally a huge Math Club thank you to all 3 of them.
Hey, Pete, I was looking at Mrs. Morrison's plans for the rest of the week, and it looks like there's a big field trip to the zoo coming up. Do you think there'll be a lot of math that we can find there?
Oh, absolutely. Math is everywhere.
Awesome. Well, class, if we do end up at the zoo, we'll be sure to ask for your help. But for now, let's just enjoy some pizza. Bye, Math Club Junior. We'll see you all next time.